Okay, section 3.7 part D, we're going to still be solving functions that are inequalities, but we're going to use a different process called the interval test. So an interval test method can be used to solve polynomial or rational inequalities. So this is just another method from the zeros method. So the x-intercepts and the vertical asymptotes are noted on the x-axis, and then you're going to choose a test number from each interval, and that's going to tell you what the sign of the function is throughout that entire interval. So looking at this next example here, we're going to solve the inequality using the interval test. Not sure what yours has here, but we should have a +6 on the end of this numerator here. So if you don't have it, go ahead and write it in on your notes. Okay, so the first thing we're going to do is we have to test zeros for x-intercepts and vertical asymptotes. So we're going to set this into an equation that everything's on one side equal to 0. So we're going to start by moving that 1 over x over to the left side. So we're going to subtract that to the left side, and now it's less than or equal to 0. Now this is two fractions, so we're going to actually put it together into one to make it look like a rational function. So we need a common denominator, so that's going to be having an x multiplied to the top and bottom of the first fraction, and an x minus 6 has to be multiplied to the top and bottom of the second fraction. That leaves us x squared plus 6x in the first numerator, and then this negative is going to get distributed to both of these to make it negative x plus 6 in the second numerator. So that now they have a common denominator all in one fraction of x times x minus 6. And if you combine that in the numerator, this is going to be an x squared plus 5x plus 6, which we can factor. So our new numerator is x plus 3 times x plus 2. And that's still over our common denominator of x over x minus 6. This looks the same thing as the last time. This is a rational function that we're going to be testing the zeros as well as the vertical asymptotes. So if we look at our x-axis and put those numbers on chronologically, it starts at -3 and goes to -2, and then 0 and 6. Now 0 and 6 are where your vertical asymptotes are there, so we don't have them equal to those points. Those are undefined, so we're going to have open circles at 0 and 6. But the two places on the top are actually the zeros of the function. That's where it equals 0, so we're going to have those filled in where they have a quantity that's equal to it. So at this point, instead of looking at sign changes and places where it goes through and bounces, etc., we're going to look at the values of the function at each one of these set intervals. So we're going to pick a test number. So we're going to start on the left side. We're going to pick -3. We're going to go to the left of that. That would be like something like -4. So all I'm going to do is look at the signs when I plug it into this function. So I'm going to plug in -4, and -4 plus 3 is a negative number. -4 plus 2 is also a negative number. And we're going to divide that by -4, which is negative. And -4 minus 6 is also a negative number. So a negative times a negative is a positive, over a negative times a negative is a positive, and a positive divided by a positive is positive. So we're just looking if it's positive or negative above or below the axis. So we keep going through this entire function, picking one number in each of these intervals to test the signs. So I'm going to test -2.5. Plug it into this function. -2.5 in each of these 4 sections of the rational function will give you a positive number, a negative number, divided by a negative number times a negative number. All of that is a negative divided by a positive. That's negative. Keep going to the next section. I'm going to pick -1 because that's in between -2 and 0. And that would give us a positive times a positive divided by a negative times a negative. That's a positive divided by a positive, which is positive. Going for the next section, I'm going to pick the easiest number I can think of, which would be 1. Plugging that in, it would be positive times a positive all over a positive times a negative. So that again is going to be a positive divided by a negative is negative. One more section, one more interval to test. I'm going to test the number right next to the 6 is 7. That would give us a positive times a positive over a positive times a positive, which is positive. If you look at each one of these intervals, we're looking for when it's less than or equal to 0. So that happens from the -3 to the -2, and also from 0 to 6. So now if we're putting this in interval notation, our x's are an element of the set from -3 to -2, and it includes both those values, so we use close brackets. Or it can be in between the interval from 0 to 6, but not including those 2 points because those would represent the vertical asymptotes.